Boom! What is up, everybody, and welcome back to another video. This is Jacob Tucker, and in today's video, I'm going to be starting a new series called Contract Review, where I basically just casually walk through some Cadence smart contracts. Some of them I'll have never seen before, some of them I'll have already seen, and I'm going to give some, reviews based on what I think about them. Maybe some things that could be done differently, some things I would have added, removed, changed about them if I had written them. And hopefully this will allow you to sort of get into my mind about how I approach contracts, and some helpful patterns that I see all the time. And so without further ado, today we're going to be reviewing the easiest one, pretty much, which is the NFT contracts. So I'm going to be, each one of these videos, I'm going to sort of show where I'm getting them from. And then I'm going to, change them around in this repo called Contract Reviews. And I'm going to upload all these on GitHub so that you can go and see maybe, this code that I'm changing, on my GitHub. So yeah, let's just write. All I did so far was I just copy and pasted these contracts, including the fungible token one, into my VS Code. So let's dive right into it. Now in this video, I'm going to be reviewing the example NFT and the non-fungible token interface. So this is the non-fungible token standard that's been discussed very much. And this is the example NFT contract that the Flow team provides. So I'm going to just, I've seen these a lot before, so I have a lot of stuff in mind already. But I'm not going to focus too much on the fungible token and metadata views contracts, even though they're used in here. We're more going to focus on the non-fungible token part, since those were added quite recently. All right, so let's jump into it. So as most of you probably know, the non-fungible token .cdc file, this is the non-fungible token standard. It's a contract interface that gets implemented by ExampleNFT here. And, with all this being said, if at any point during the series you're confused about some syntax, I'll explain it along the way, but if you're confused about syntax or want to know more about it, I have a whole Cadence series on my channel, so feel free to check that out. So, yeah, let's just walk through it. So I'm going to sort of get you into my head a little bit about what I'm seeing here. So, this is just a total supply that keeps track of all the tokens. There's a few events here. There's a contract initialized event, which is, it's whatever. It's it's easy to have there, I guess. And that gets, sent out at the bottom here when they emit the contract initialized. That's when it gets deployed. There's a withdraw and a deposit event. These two are both fine. You need withdraw and deposit events. Now, one thing I'm going to add here is a transfer event, but we'll get to this in a bit. These are just storage paths and public paths. These are great. One of the things I always recommend is having like a, storage path or a public path variable. People can read from it and see where you're storing, user collections and stuff like that. So it's great to have these here. And then, quickly we jump into the, NFT resource. So this implements the non-fungible token to INFT. There's actually some debate about whether or not, this is even helpful. It's not, to be honest with you, it's not. Because if you have this resource here, if we were to get rid of this, for example, and just completely get rid of this in the standard, and then, this would work totally fine. And then if we just got rid of this, it would also work totally fine. So INFT really doesn't do anything. There's no point for it. So I'm actually going to go ahead and just remove it because I don't really see a reason for it. So that's that. And the reason for that is because if in the non-fungible token.cdc file, if you require, this resource here, that the user has a public resource NFT with an ID field, then by default, the user has to have it anyway. So there's no reason to duplicate code and increase storage costs. So that's the first thing I'm going to get rid of off the bat. I said I'm not going to really review the metadata that much in this video. The name, description, thumbnail, and royalties here really tie into the metadata standard, so I'm not really going to go over that much. But one of the things that I always do in my contracts is I never like to pass in an ID my NFTs. Now, you'll see that if we scroll down a little bit to where we get to the NFT minter, this is what's actually minting NFTs. You'll see that it's actually passing in the ID to create the NFT. And, so passing the total supply. So, the total supply starts at 0. And then every time an NFT gets minted, its ID goes up, right? So 0, 1, 2, 3, 4, stuff like that. I don't personally like this. And the reason why I don't like this is because, well, number one, there's two problems here, right? Number one is that they're updating the total supply in the mint NFT function, which is fine. It's going to work. The only thing is that, if this contract ever gets updated, if there's for some reason another way to ever mint these NFTs, it's possible that the person who is minting those NFTs forgets to include this line here to update the total supply. So what I like to do instead is instead of having the total supply inside the mint NFT function like I do there, I always like to put it in the init function of the resource itself. Now this ties into a greater theme, and I'm also going to change this to 1 because that's old Cadence right there. But this ties into a greater theme of, you know, when you're updating some sort of state based on the creation of some resource, you always want to do that at the lowest level possible. What I mean by that is, like in this case, because we're updating the total supply every time an NFT gets minted, you want to do that at the lowest level, which is actually when it's being created, not when a function is being called to create it, if that makes sense. That's another change I would make for sure. And then with that being said, I also would not pass in the ID to the NFT. I think it makes no sense. Of course, you can do it this way, and this is something that, like, if you want your IDs to be incremental like that, if you want them to be 0, 1, 2, 3, you can totally do that. But I wouldn't recommend doing that. What you could do, for example, is in here you could just say self.id equals example NFT dot total supply, and then that way you don't have to pass it in. And again, that way it's a lot simpler, because if, for example, we accidentally had a different mint NFT function and they just passed in the wrong total supply or something, then it wouldn't work, right? But if you do it inside the actual creation of the NFT itself, you always know that it's going to work. And so this will make sure that the IDs are, 0, 1, 2, 3, 4, stuff like that. But I actually would even go a step further. And I, in all my NFT projects, never like to use incremental IDs for my NFTs, because in a way, like, this is sort of a side point, but like in a way, it sort of implies rarity, right? If someone has NFT 0, that's sort of better than NFT 15, even if you don't mean that to be true. And in addition to that, in this case, we've solved the problem where the total supply gets messed up. But to really ensure that every single NFT is unique, there's no reason not to use self.uuid. And the reason for this is because self.uuid is a unique identifier across every single resource on the in Cadence. So there will never ever be a resource with the same UUID. And so for that reason, I think that it's actually better to use the UUID itself for the ID instead. Now, to be honest with you, like, I would even go, like, maybe I would even debate going a step further and not even having an ID at all, and instead referencing the NFT based on its UUID. Because here we're sort of duplicating effort, because now both the ID and the UUID of these resources are the same exact thing. However, because it's a non-fungible token, and we want to be really clear that the ID is actually unique, this is fine to do, and so I'm gonna leave it at that. But I would, I would be up to having the debate of getting rid of the ID itself. So that is one. Those are a few things I would change right there. Now, these are all metadata standard stuff. I'll save that for another video. But honestly, I think BR Tech has done a great job with this anyway. So we're gonna keep going from there. Now, one other thing, so now we move on to the collection itself, right? And so the collection gets really interesting because there's actually quite a few things that I would change here. Right off the bat, what I would change is this owned NFTs dictionary. Now, the reason for this is because right now in Cadence, there's an anti-pattern, or anti-pattern. I don't know how you say it, to be honest, in English. But there's an anti-pattern where you can actually withdraw from public fields if they're dictionaries and arrays. Now, this is pretty dangerous because, if you ever have a contract, if we were to go up here, for example, and I made a public variable stuff and just did like a string to like NFT mapping, for example, this is really dangerous because you will actually, because it's public and it's a dictionary, anybody can actually withdraw from this dictionary, even if this is, only writable within the scope of this contract. An anti-pattern. And so I always mention this when people have public structured dictionaries at the top level of their contract. Very dangerous. You always have to make it access counter contract, like this. However, this is soon being fixed in, newer updates of Cadence. So I'm really excited for that. I believe around the June spork, that's going to be changed where you can no longer withdraw from that. But anyway, my point is that enforcing owned NFTs to be public is a bit strange. Now, depending on who you talk to, you'll get different arguments about whether or not users should always be, allowed to view their NFTs like that. But right now in current Cadence, let's say you have a withdraw function that, updates some state or makes sure that the user, is withdrawing it only if X is true. It doesn't matter because the user can always withdraw from this anyway. They can completely skip the withdraw function, and it's pretty dangerous, actually. And so, again, some people will argue for it, but I absolutely do not. And so one thing that I would change in this contract is in the non-fungible token standard. Oh, and the reason for this, by the way, is because look, if I try to change this to access account, fix that problem, look what happens. It says, collection does not conform to the resource, whatever. And the reason it's saying that is because inside of the non-fungible token standard, you can see it's actually enforced that it is public right here. As you probably know from Cadence, or if you don't know, an interface can always be more restrictive than the implementing version, but it's not the other way around. So what I would argue for is making this access self, and by doing that, well, let's actually see the error here. Oh, I guess it wants us to put private, I guess. Yeah, I have literally no idea why it's saying that, actually. Okay, maybe we'll revisit I don't know why it's saying that's actually pretty strange why it's saying that. Okay, so for some reason it doesn't like private, but we'll put access contract for now. I'm gonna revisit this at the end of this video. But I would put access contract here. And the reason for that is because that way inside of our implementing type, we can either allow the user to put public, the developer, or we can restrict this to access contract ourselves. And that way, the user can never actually withdraw from owned NFTs, and instead they have to go through the withdraw function. Now, again, none of this is going to really matter when the June sport comes around and the user can't withdraw from owned NFTs. However, I still think it should be in the developer's hands to do what they want with the owned NFTs dictionary. And so making this the most restrictive possible so that the implementer can have the most freedom, I always think is the best case scenario. That's change number one. I would keep the withdraw function. I think it's great. This is great. Also, I think deposit is great. One thing I always do for readability's sake, this really doesn't matter at all. You can do it totally either way you want. But I don't, for some reason, I just don't like the double movement here. What I would do is I would just use the force move operator. So self.ownedNFTs.id and force move in the token. And that way you don't have to do this destroy at the end. So I don't know if that actually fixes like efficiency or storage costs or gas costs, to be honest. I think it might. I think it might actually save some gas by doing that. Again, gas prices on this flow are very minimal, so it doesn't really matter. But I believe that would save some gas because you're saving or destroy. And in this case, because of the fact that we've changed the ID of the NFT to always be the UUID, it's actually impossible for anything to exist at this location anyway. So the force move operator will always work. It's impossible for it not to. So that is that. And then we emit a deposit function, and all is great. Now, one other thing I would add here is a transfer function. And the reason for this is because of events. Now, right now, when you are trying to read blockchain, event data, you can read that someone, withdrew, you can read that someone deposited, but you don't immediately know to where, right? You know that, for example, this person deposited an NFT with ID to this, collection, but we don't know where the NFT came from. But transfer allows us to, record that information. So what we can do is we can take in an ID, which is UN64, and we can take in a recipient, which we can just make, I don't know, we can make this a non-fungible token dot collection. And by doing that, we can actually, well, what's the error here? Ambiguous type. So, okay. Oh, it's because this should be, this should be a collection public. Sorry. I forgot to add that little thing there. Okay. And so that way in here, what you can do is you can, let's see, you can go ahead and do, I'm just going to copy and paste code here. There's no reason not to, but you can bring out the token with that ID. So let's bring out the token with that ID. And then what we can do is we can deposit the recipient. So deposit, and then move in the token right here. Now, what we can do in addition is we can add an event here called transfer. And this is where, the whole reason for the transfer function comes in, and we can add a new event called transfer. And that way we know exactly where we're transferring from and who we're transferring to. And so we can do the same thing, transfer, from an address optional, to an address optional. And then down here, we can say the ID is ID. We can say the from is self.owner.address. And the to is recipient.owner.address. Like that. And that way, again, we can track more easily where these NFTs are going to. And so, in addition to that, I would add this transfer function to the NFT standard, and we can go ahead and do that right. Boom. So now it's added to the standard, and then it is all good. Get IDs, I think, is perfectly fine. Borrow NFT, I think, is also perfectly fine. Now, this is a bit interesting when we talk about the metadata standard. Again, I didn't really want to dive into the metadata standard too much. However, if we think about, what this function is actually doing, it's returning a reference to the NFT itself. Well, to back up a little bit, this function is returning a reference to a non-fungible token NFT, which means you can only access his ID. And this is returning a optional reference to an example NFT .nft, which is allows us to access things like the name, the description, the thumbnail, all that kind of stuff, right? The cool part is that the only reason you would actually ever need a reference to this is assuming we have implemented the metadata standard, is if you have functions on the NFT. But most of the time, you don't really have functions on your NFT. In this case, we don't. We only have get views and resolve view, but these are both covered by the metadata views.resolver interface. So there's actually no reason to return a reference to an NFT here. So I would actually go ahead and delete this entire thing because there's simply no reason for it. And we could even get rid of it here. And this will reduce some of the storage costs in this contract. Again, just to reiterate, what the heck is that word? Reiterate, I think. It'll just, it'll reduce storage costs, not by much because it is Flow and we love Flow, but, that is sort of the point there. And now, we can just use this function to return a reference to a metadata views.resolver, which, if you notice, is this interface right here. And metadata views.resolver includes these two functions, so we can call them totally fine. And then that way, in this case, theoretically, we would be returning the name, description, and thumbnail and royalties in some sort of view, which we do right here, right? The name, the description, the thumbnail, and then the royalties. And so we can totally get rid of that other function that we just got rid of. So woohoo. So that is done. That's one thing I would change. And then moving on, some of the other things here, I think this is totally fine. I like this a lot. I mean, there's not really anything to dislike about it. It's perfectly fine. NFT Minter, I think, is good. There's a mint NFT function here. It allows you to receive a name, description, thumbnail, royalties. All this stuff is totally fine. We fixed a lot of this up earlier. One thing I will say is that this right here often bothers me. I really don't. I'm very hesitant to use a reference to a general type. I don't like seeing it a lot. But because this is and the reason for that is because sometimes if you have an NFT project, a lot of people will come to me and they'll have an NFT project, right? And they say they want to make some NFT project and they have these collectibles and all that, and they want to make their own collection. And so they'll go to this example NFT repo to learn a lot from it. The issue is that what happens is they'll look at something like this and not realize that this allows the recipient to deposit into any collection they want. And what I mean by that is, like, let's say I went to, Ballers NFT, right? And I wanted to, mint a Ballers. The Ballers team might want you to mint a Ballers NFT into your Ballers collection, but I could pass in my Flovatar collection here and mint into my Flovatar collection. Now, it's not necessarily a problem, but it's something to note. And so if you really want users to store their NFTs only in your collection, then I would add ExampleNFT here, .collection, to do that. Now, again, it's not necessary, but it's one thing I'll mention, and I'll leave there because I like this a little bit better. But if you want the other piece of functionality, then delete it. So, that's totally up to you. Yeah, and so that's about it. With that being said, I mean, this is a very stupid change, but personally, if you've ever seen me write contracts, I always do these with capital letters. I don't like them with lowercase letters. And that's all I would say. So, this is very important as well. One other thing that's not I don't know why actually it's not done. I get kind of confused by it. I think it's because they just forgot to add it. But when you actually link the collection here, they actually forgot to link metadata views.resolver collection here. So I'm not entirely sure why that was forgotten. Because it's not covered by this, and it's also not covered by this, right? So, and what I mean by this is like what's being covered is this function right here, the borrow view resolver. So that's actually not even exposed to the public, and you could actually make an argument to add this function to this collection. But there's no reason to because it's already covered by this interface right here, metadata views.resolver collection. So these are all the changes I would make to the standard. Oh, and I forgot to mention that we should also add a new event here. Let's add this transfer event to the standard. Something I think should be in every standard. And we can add some, comments here and just say like, just because I'm gonna be pushing this to GitHub. The event that is emitted when a token is transferred to another collection. How do you spell transferred? Is it bars? I have no idea. It indicates that the owner of the collection that it was withdrawn from and deposited to. Now, one other thing I actually forgot to mention during the video, that's why there was like a cut there. I actually went back and I was thinking about, how do we want to, make sure that the user is transferring the correct ID or the intended ID in their transfer function, not tricking the user. Because you can see that actually in the provider function here, it is a post condition that the result ID or aka the NFT that's returned was the one that's requested. So we should actually add some post condition answer event to make sure that the developer isn't tricking the what NFT they're actually transferring. So one way that we can do that is we can add a post condition here in the transfer event in the standard that says that self.owned NFTs at ID now equals nil after this transfer happened. And if not, we can say you didn't transfer the intended NFT. And again, what this does is that after post runs after the event's over. So after the event's over, self-owned NFTs at ID it no longer exists, right? But if we want to take it a step further, we could even say recipient.borrow NFT at the ID does not equal nil. And what this will say is that if we look in the recipients collection, we can make sure that their borrow NFT, like this borrow NFT function, is supposed to be returning a reference to an NFT, and it'll panic actually if it doesn't exist. We can use that functionality to say, hey, make sure that the recipient actually contains this ID, and if they don't, then say again you the so boom, those are two conditions I would add. And yeah, that's about it. So thanks everyone for watching, and I will see you in other contract reviews. If you enjoyed this, make sure to leave a comment and let me know. Thanks.